This is my Starrett 673 bench micrometer. I'll do a 360 and then explain the different parts. This is a spindle. It's graduated in tenths or 10,000ths of an inch. This is the speeder knob on the side for fast movement, and then this is for fine movement. This is the spindle lock bolt. This is the movable anvil, spring tensioned anvil. You can see as you move it back to insert your part, then let it go. These are carbide faces, very hard and last a long time. This is a dial gauge. It's graduated in 50 millionths of an inch per division, and it can be adjusted. It can be fine adjusted to set the 0 point in just a minute. This is the anvil tension adjustment. It can be adjusted from a ½ pound to 3 pounds. Before I make any measurements, I put a piece of laser printer paper in there in between the faces, and I'll set it for 0 tension, and I'll pull it and then release it. You want to release the pressure before you pull the paper out, because if you don't, the faces will snap together, and because tungsten carbide is brittle, very hard but brittle, it could chip or break the areas on the face. First, I'll set the 0 point reference. I'll put the spindle exactly on 0, and I will put the dial exactly on 0, and both the long dial and the short dial will both be exactly on 0. The first gauge block I'll measure is 0.1 inches. It's a Starrett crow block, grade 0. I'll run slightly over 0.1 inches, release the anvil, move it back and forth to make sure it's seated good, and then set this to 0, exactly on 0. And that's reading slightly less than 50 millionths, probably about 40 millionths. And the Starrett states that the accuracy of this is plus or minus 50 millionths of an inch, so it's within tolerance. My room is 74 degrees, and the Starrett equation for temperature adjustment is the coefficient of expansion for the gauge block, which for the crow block Starrett crow block is 4.7 millionths of an inch times the difference in temperature from 68, which is 6 degrees, times the gauge block length, which is 0.1 inches, and that's 2.82 microinches longer, and the tolerance on the grade on the block is plus or minus 5 microinches. So we're looking at less than 3 microinches plus or minus, which is this gauge cannot measure that close, so we're good. Next, I'll measure a 1-inch block. Get a little closer. Run it out to slightly over 1 inch using the speeder. And these blocks have been cleaned. I put them in there, move it back and forth to make sure it's seated good, because you can tell when it is, it'll be smooth. Then I go to set it on exactly 0. And that reads slightly under 50 millionths of an inch, probably 40 millionths of an inch. And according to Starrett, that would be 4.7 millionths times the difference in 6 degrees difference in temperature times 1 inch, which is 28.2 microinches plus or minus 6 microinches, so approximately 30 microinches, and we're sitting at approximately 40 microinches, so it is well within the 50 microinch tolerance. Next, I'll check a 2-inch gauge block. This is Starrett, and it's a steel block, grade AS1. Move the dial slightly over 2 inches. Release the pressure. Move it back and forth. You can see if it's lined up right, when you move it back and forth, the dial won't change. Then move this to 0, exactly 0, and that's reading about 120 microinches over 1 inch. And according to the Starrett equation, the coefficient of expansion of Starrett steel is 6.4 microinches per degrees Fahrenheit times 6 degrees times 2 inches is 76.8 microinches longer, plus or minus 16 microinches, so approximately 80 microinches. And this is about 120, so it's still within the 50 plus or minus 50 microinch tolerance that Starrett states. There's a very nice fitted box for this micrometer, which I'll show next. This is the custom fitted box for the Starrett 673. This is the base. And the top. Seen a lot of use, but it's still very accurate. Says something for good old American technology. I'll show you how to put it on the case without damaging it. There are finger holes on the side and they fit. There are holes here to fit under it, and when you put the top on it, there are supports in here and here that'll keep it from shaking, so you can actually ship it in this wooden box. And just be sure you don't pick it up by the spindle and the gate and the adjustment here, or you could cause the alignment to go out and maybe even other problems. So I hope you enjoyed this video.